Welcome back to Chem 101. In this video I want to write ionic formulas. And there's really two approaches to this. What we're doing is we're pairing up cations with anions. So our positively charged ions with our negatively charged ions. So you can either look at them and see how they pair up. 1 plus and 1 minus. They just pair up. This would be NH4Br. 2 plus and 1 minus. So we need 2 of these, right? We need beryllium with 2 bromines because this is 2 plus and this is 1 minus. Everything needs to be equal. There's another way that you can do this though, if you don't just see how to connect them together. So let me show you how to do that. So we start off with just taking the 2 we're pairing together. Let's take beryllium and bromine. So what you want to do is you want to start with your ions and you bring them together. And what we're going to do is we're going to move their charges. So their charge here, we're not really going to move their charges, but we're going to take this number and bring it down here. And do the same here. We're going to move this and bring it down there. So that what we end up with is beryllium and bromine with a 1 and a 2 next to it, right? Now when there's a 1, we can just drop it. We don't need to keep the 1. Beryllium, bromine, beryllium, bromine. So you get the same formula. Now let's try it again. Let's try it with a different one. This cross kind of, it's not really canceling, I don't know what to call it, just switching the charge from one side to the other. Let's do aluminum and oxygen, O2. 2 minus. Okay, you might look at this and say, okay, well the lowest common denominator here, lowest common factor is 6, right? So I probably need 2 aluminums and 3 oxygens. But if you don't see that right away, that's why we have this other method. So the 3 will move down here. The 2 will move there. And we'll end up with Al2O3. And again, let me give you another way to kind of see that. If we have 2 aluminums, each with a 3 plus charge, it makes sense that since this is 6 plus altogether, that we're going to need 3 oxygens because 2, 2, and 2 is 6. So that's what this is coming from, Al2O3. So you have this way. Now there's one more step that I haven't shown yet, and that's when you have things with the same charge. For example, beryllium sulfate. So Be2 plus, sulfate, SO4, 2 minus. Now we can do a cross here, so this will be a 2 down here, and this will be a 2 down here. Now when we write this, Be2, we want to put parentheses, SO4, 2, to show that this 2 is for everything here, the whole sulfate, not just 2 times the oxygen. And then if we can, we want to reduce this to the lowest common factor, lowest common denominator. So we can divide both of these by 2. We can divide this whole thing by 2 really and just get BeSO4. And so you might have seen that already if you notice that SO4 2 minus pairs up with beryllium 2 plus. But if you want to use this method where we cross the charges to become the subscripts, just remember that if you have something that can be reduced further, you want to reduce it further. All right, that's it, right? Writing ionic compounds. Maybe we can do one more. Maybe we can do one more. How about ammonium with oxygen over here, O2, 2 minus. Again, the 2 will come down here, the 1 we'll come over here and we'll have NH4 2O, right? With the 1, but we don't have to show the 1. This would be ammonium oxide. All right. So in the next video, definitely this time, we'll get to acids.